FMEA and reference FMEAs and control plans, we expanded that into something a little bit more comprehensive, which is what we have this week. So today we're going to focus on what are the specific shell requirements in 13100 for Process FMEA and control plans, and how that links then to the Reference Manual 13004. We will also give a high-level overview of what a 13004 FMEA looks like. So you might notice once we've been through it that it's quite different to how you've done FMEAs in the past. But hopefully when we go through the material, you'll understand why it's necessary, I think, to define the requirements for FMEA in the way we have in this standard and in this guidance manual. So that's really the intent of today. Look at 13100 and provide an overview of the FMEA approach. Tomorrow, we're going to go into much more detail, step by step, through the Process FMEA, showing you some good examples of what success looks like, letting you know about some of the problems we have or some of the traps that it's quite easy to fall into when you're doing your Process FMEA. And it's one of those frustrating things, I think, for all of us, that it takes just as much effort to do a poor FMEA sometimes as a good FMEA. So it's a big process. Making sure that we're focused on what it needs to be focused on, using that cross-functional team, is really important. So tomorrow we're going to go step by step through that, and hopefully that will help you be able to understand exactly where your organization is and how it deploys FMEAs. And then on session 3, we're going to look at something called reference FMEAs, which are building blocks we can create once and use many times. And that has two effects. One, because it's captured all of our latest thinking, it will improve the quality of our Process FMEAs. But because they are pre-prepared building blocks, it will also drastically reduce the amount of time the team requires to actually produce an FMEA at part level going forward. So it's a really excellent way of investing time up front to make sure that we are able to be agile with Process FMEAs and allow our teams thinking time to take the actions that come out of the Process FMEAs and to implement those, rather than going through the technical administration that FMEAs can often become. Also on the third webinar, we're going to show how you can create a control plan from the information that's in the Process FMEA. Okay, so that's what we've got laid out. Hopefully these sort of 2-hour chunks. Tomorrow we might need a bit more time. That really depends on questions. This seemed to be a good way of dividing it up and not making it, a big full day session to allow more people to join. So just an introduction to myself. I've been in Rolls-Royce now since 2005. I'm the quality exec for civil aerospace assembly and test operations. And before that, I had 16 years working in the automotive industry. Before coming to Rolls-Royce, I worked for a company called Cosworth Technology. Cosworth, some of you may know, involved in Formula One back in the 80s and 90s. We were actually taken over by Audi to do high performance engines. And so before coming to Rolls-Royce, I was making engines of a different type for Audi, but also for Aston Martin and Bentley. I was a founding member of the AESQ back in 2013, when GE, Pratt & Whitney, Safran and Rolls-Royce got together to look at the opportunity for collaboration to create common standards so we could give a single message to the shared external supply chain. I led the writing team for 13100, 13003, which is all about measurement systems analysis, and I'm now the team leader for 13004 subject matter interest group. And we'll come back to that a little bit later on of how that group can help with the future support for deployment of Process FMEAs. The other thing that I'm hoping to share on these 3 webinars, over the last 4 years in Rolls-Royce, we've rolled out a Zero Defects program, which has involved taking all of our senior leaders from board members right down to plant leadership through the principles of zero defects and defect prevention. And one of the core tools we looked at clearly was Process FMEA. We also took that to our top suppliers, about 140 suppliers in all. And so those conversations helped to inform some of the issues around Process FMEA that we will cover in the next 3 days as well. So I'll try and capture as much of that as I can as we go through. But I'm also being helped and supported over the next 3 days by Becky Lemon of SAE and Rudolph Brownreader from MTU. So Becky, could I ask you to introduce yourself?
Thanks, Ian. Good morning, everyone, or good afternoon, or good evening, depending on where you're calling in from. My name again is Becky Lemon. I'm the program manager for the AESQ group and SAE International, and also the SAE ITC, the Industry Technologies Consortia. I will be helping Ian out today with the polling questions. We're going to be using Slido for the polling. It's completely anonymous. You will see it on your screen, and what you see are the results and the voting. So please help us to get some results there and submit your vote when we do our first poll today. Thanks.
Thanks, Becky. And Rudy?
Yeah, thank you, Ian. So also from my side, good morning, good afternoon, and in some countries, good evening. My name is Rudolph Braunrieder. I'm a quality manager at MTU Aero Engines in Munich. So to my person, I have been working in various quality areas for 25 years and have been intensively involved with preventive and reactive quality methods for more than 20 years. So at the AESQ, I was involved in the creation of the standards AS13100, RM13004 defect prevention tools, and RM13006 process control methods. So my job in this webinar today and the following days is to be the chat and question manager. So please use the chat function to ask questions or to make any statements. I will collect your questions and Ian will answer them during the break provided for this purpose. So let me say, I'm very pleased to support Ian Ricks and wish you all a successful webinar. Thank you.
Thanks, Rudy. And just to manage expectations, I will answer the questions that I can. I have asked Rudy to be gentle with me in terms of some of the questions that are going to come through. So hopefully I will be able to answer some as they come in. So thanks, Rudy. Thanks, Becky. So that's enough of who we are, just to say who we have in the call today. So we were really overwhelmed, I think, with the amount of interest in these webinars. And as of last night, we had over 740 people register for this event, and you can see where they are across the globe. That represents 250 companies in 27 countries. So I recognize, and I know Becky and Rudy mentioned it, but we've got people like Jim Wilson from Pratt & Whitney on the west coast of America just waking up to join us. So thanks, Jim, for joining so early. And we've got people like Hong Li Zhu from Sansuzhou waking up, oh sorry, not waking up, but actually finished his day 10 o'clock at night out in China. Thank you very much for staying up so late to take part in it. And I know we're recording this, and but I really hope we can get some engagement and some interaction as we go through this too. So thank you very much for making the time and showing the interest in this webinar. It's greatly appreciated. I haven't been able to capture all 250 logos, but just to give you a sense of who we have in here. We have representatives from Airbus, Boeing, Lockheed Martin. We have all of the AESQ member companies and a whole list of large aerospace organizations with loads of experience, and all of whom are kind of impacted by having to deploy 13,100, and clearly as part of that APQP and Process FMEA. So welcome, thank you very much for joining. Today's couple of hours we're going to break into 3 sections. So I'm going to cover what are the 13,100 requirements. So really the shall statements of when shall you do an FMEA, or what are some of the explicit requirements from that. We will then look at a fairly high level overview of Process FMEA that meets the intent of the RM13004, to kind of highlight some of the key differences we picked up when discussing this with the external supply chain and even across our own companies, to try and get a calibration of this is what we mean by a 13,004 Process FMEA. And then finally, where can you go to get more information? How can you get more involved? How can you request support as we go forward? I'll cover that at the end. And in between, as Rudy mentioned, we will pause for some questions as we go through. Send those questions in as soon as it comes in, it pops into your head. You don't have to wait until the section on questions, and then Rudy will gather those together. Okay, so let's begin. So the first thing to say is, in this industry, and especially aero engine manufacturers, I have to admit I'm biased, but the things we do are truly amazing. When you think we have 25,000 components we bring together, that can actually allow our customers really to defy gravity and actually fly from Australia to Europe in sort of 30 hours with the efficiency. Somebody told me the other day that per person, the amount of fuel used to take somebody from the UK to China on one of these large aircraft is equivalent to the same amount of fuel they would need if they did it in a Ford compact. So, over the years, we've seen so many remarkable achievements in terms of the power, the distance, the noise levels, the efficiency of these engines. We've got to keep reminding ourselves, we do an awful lot of things really, really well to achieve that. But when you talk about quality in aerospace, and we also know the consequences of poor quality can be really serious. It's the nature of the products that we make. And air travel is still one of the safest modes of travel. So per person, per mile, it is still one of the safest. Apparently, you're twice as likely to get struck by lightning than be in an aeroplane crash. So, although it's very infrequent, when it does go wrong, the seriousness is we can't contemplate just the impact that these things have. And now with social media, it's all on social media even before the plane lands. We have a great responsibility to actually keep our customers, passengers, and our families safe, because we all fly on these things when we go on holiday, when we go for business. That for us is a really key part of why these standards are so important. And quality doesn't just happen, we know that. One of the great quotes I love from the sort of, I guess it's the late 70s, early 80s, was Philip Crosby, who wrote, many books, but had the concept of zero defects. Quality has to be caused, not controlled. In other words, we have to plan for quality and how we prevent quality non-conformances. You can't inspect it in. And one of the key things with the Rolls-Royce Zero Defects program was this idea. When I joined Rolls-Royce, my first aerospace company from automotive, I was quite shocked how much we relied on inspection compared to, say, where I'd been in automotive. And that is one of the key challenges, I think, not just within Rolls-Royce, not within aero engine manufacturers, but across the supply chain. We do lag behind some of the defect prevention maturity tools of other industries like automotive. We know that if you've got a capable gauge, that capable gauge could have 10% error, 20% error. When you have visual inspection, our acceptance threshold is 80% defective. So we're really saying, inspection will not find everything. The only way to make sure things don't go wrong and we don't ship non-conformance is not to create it in the first place. And that's where APQP and PPAP are so important to us as we go forward. And out of all of the tools in APQP and PPAP, FMEA is by far our most powerful defect prevention tool. So when the AESQ came together to look at what we can harmonize, and we drew up a list in each company of what are some of the key areas we want to improve. It was really surprising just how similar those lists were between each of the manufacturers. And the key theme was all around things like measurement systems analysis, FMEA, process control, all of the key defect prevention methods. And maybe we shouldn't be surprised, because as an industry, as I just said, we aren't as mature as some of the others. But the real focus of 13100 and the reference manuals, by building on what we already have with 9100 and 9145, what we're trying to do is enhance that with all of the learning that we have to bolster our defect prevention tool set. So the standard was published in March. All of these reference manuals, you can see things like process control, defect prevention tools, MSA, etc. These are all free to download off the AESQ website, and there's some fantastic material in there for you to be able to get access to. Today, we're going to focus very much on the requirements of 13100 and the reference manual RM13004. So hopefully you've read 13100. Let me just summarize where we're going to focus. So 13100 has 3 chapters. Chapter A are all of the additional requirements that used to be in Rolls-Royce's Sabre requirements, or GE's S1000. And we've harmonized as many as we can, and we've aligned them to the same structure of 9100, and you'll find those in Chapter A. Chapter B, we've done exactly the same, but this time it's aligned to AS9145 around APQP and PPAP. And then in Chapter C, we've focused in on the tools that used to be in AS13004, plus a few others. And those are there to define the hard requirements for each of those when we're using it to support APQP and PPAP. So when you look at Chapter C, you'll see there's 8 different chapters. In these series of webinars, we're going to focus on 21.4, which is all around Process FMEA, and 21.6, which is the process control plan. Okay. Now, one of the great tools we've got on our website, which I know in the communications Becky sent out to everybody, recommended that you watch before you come to this webinar. But I would say, it's a superb video to show how each of these key defect prevention tools come together. It's got the references to AS13100 and the reference manuals. You can download it, you can use it within your own organization. But it's a really great way, I think, in a 3.5-minute video to get the key messages across to senior leaders, to technical leaders of what AESQ deployment actually looks like, and why these tools, however good you are at one of them, the fact that it works as a system, we have to be good at all of them. And that's our challenge as an aerospace industry, I think, and especially within aero engines. We have to be able to demonstrate we can get really, really good at deploying APQP and PPAP and the tools that are within APQP and PPAP. And that's why AESQ are running webinars and supplier forums and trying to raise the capability of our own organizations, but also of our shared supply chains. So I would encourage you, if you haven't seen it, go onto the website or download it. I think it's on YouTube, and you can easily download it from there. So, Becky, let's see if the polling works. Would you like to set up the first
thanks,
poll?
Ian. I will start the first poll here. We're using Slido polling today, so you should be able to see a poll on your screen, and feel free to start voting yes or no. Have you read AS13100? There is a chance that a handful of people may not have access to Slido due to security or whatever, but we are getting a lot of votes pouring in here right now. If you don't see the Slido poll, maybe look down at the bottom right corner of your screen. There may be a button that says Slido, but yeah, it may be blocked for a few people, and that's okay. We're getting a lot of votes pouring in, so let's give it a few seconds here and see what our results show us. Looks like the yeses are catching up to the nos, maybe. A few more seconds. So right now it looks like 45% of the people are saying yes, and 56% are saying no, they have not yet read AS13100. So let's go on to our next question.
Okay. Just to let you know, Becky, I can't actually see the polling on my screen at the minute because I'm on full screen. So if you keep on audio describing it, then I'll get a sense of it. That'd be great.
Perfect. Our next question. Oh. Ian, can you go back to the slide that has the question? Sorry.
Some reason, what's happening? I've got somebody trying to get access to.
Oh, that's okay. So have you read Reference Manual 13,004, yes or no? So looks like we have 252 votes and climbing. So we'll let a few more people get in there and vote. So right now it looks like we have 23% of people are saying yes, they have read Reference Manual 13,004, and 76% are saying no. So let's move on to our next question here. How would you judge your knowledge of Process FMEA and control plans? Options: no knowledge, I know of it but no experience of using it, I've used it a few times, or I consider myself to be an expert. So we'll give everyone a few seconds to respond here. So for no knowledge, only 2%. That's pretty good. I know of it, but no experience of using it. Looks like about 28%. I have used it a few times, 57%. And then I consider myself to be an expert, 13%. So those are some good results there.
Okay.
So
Brilliant.
Ian, I'm going to turn it back over to you and deactivate the poll for the moment.
Okay, thanks, Becky. Okay, well, to be honest, from my point of view, that takes the pressure off a little bit. So I would hope that you're going to find this series of webinars really useful to kind of get into some of the key bits then about what 13,100 is asking for, but also the approach described in 13,004. So let's start with what does 13,100 require you to do on Process FMEAs? So it really comes up in three main ways, okay? And it's enacted through APQP and PPAP. So the first main way is what you might expect. So in section 8.3, we talk about how to introduce a new product. And as part of introducing a new product into the organization, APQP and PPAP is the default methodology. And just for you to know, Boeing and Airbus would expect us to use APQP and PPAP based around 9145, plus some additional things that they think are important. And therefore, we need to flow that down to our organization, but also into our external supply chain too. So when you're doing something brand new, APQP will get enacted, and APQP includes a requirement to do Process FMEA and control plans. The second one on changes, engineering changes in particular, if you change the design of a part or a system, if you change the manufacturing process used to make that part or system, or you change the source of manufacture, and that change of source could be from one of your existing plants to a new plant. It could be from one of your suppliers to another supplier. It could be from your customer is outsourcing something to you. That change of source requires the control of APQP and PPAP. So that's how that gets enacted. And as soon as you enact APQP and PPAP, one of the items you will see is Process FMEA needs to be done. The other one, which it could invoke an FMEA to be done, is if you have a corrective action. So you might be working on a corrective action report. You might use FMEA to help you identify the root cause. You might use FMEA to evaluate the effectiveness of the proposed corrective action. So that could come from your customer or from your own organization saying, really, we need to put some additional rigor around this investigation, and we're going to use an FMEA to do that. So one of the questions that comes up a lot is, do you expect us to apply FMEA retrospectively? And if you look at these three ways in which it's enacted in 13,100, clearly not. No. So moving forward, if you are given a new project, a new contract, the customer will say, and if we invoke 13,100, yes, we expect you to do APQP. Similarly, if the customer changes the design or you change the design of your product or your manufacturing process, as part of that change control, we would expect you to do that using APQP and PPAP. Now, clearly, there are ways to configure APQP and PPAP based on the type of change you have, so you might not need to do everything in there, but it's very unlikely you wouldn't be expected to do an FMEA. So it doesn't mean you have to go back and retrospectively apply it to all of the parts you're currently supplying, Rolls-Royce or GE or Safran, etc. They should be forward-looking, and there should be a clear understanding of your customer's requirements that you need to do this. I first came across APQP and PPAP back in the early 90s when it was rolled out by Ford, GM and Chrysler as part of their QS 9000. Within 2 years of following QS 9000, even if the customer stopped making it a hard requirement, I think our organization would have kept on using it because we saw the benefit of it. And that's what I would hope, if you do APQP, PPAP, FMEAs with the right intent, there should be a real business case that you get from that application. So if you were to say, and I know we've had some organizations actually go and retrospectively apply it because they had quality problems, they had a lot of different pop-ups or process capability issues, and have got the benefit from actually applying FMEA in those situations. So it wouldn't be discouraged if you wanted to apply FMEA to retrospectively, but 13,100 doesn't require you to do that. So some of the other things that are in there, and we're going to cover these over the next 2 WebExes. So you are required in section 3 to carry out your FMEA in line with the process defined in RM13004. But there's a really important piece in the wording, which is unless otherwise agreed with the customer. So there are always times when you might approach the customer and say, yeah, well, for this one, I've got a slightly alternative way of doing that. Would you allow that in this case? So there is flexibility there. It's disappointing, I think, we've got that type of flexibility there because, you know, from Rolls-Royce's point of view, I think there's very few times when we would allow an alternative approach. But with that in mind, you know, unless you've agreed it with a customer, we do expect you to do your process FMEAs that meet the intent of the reference manual. Similarly, we should be using the template that's in Reference Manual 30004 as the way of documenting your process FMEA. And there's scoring criteria for severity, occurrence and detection in there that we would expect you to use. Now, I know sometimes where this is well established in an organization, you may have a standard way of using scoring criteria, and in which case that might be something that, you know, the customer would say yes, because, you know, we don't want you to change it for the sake of it. If we can show it has the same intent, that might be okay. We will expect you to show an RPN for each failure mode potential cause combination. We'll cover that a bit more later on, but for every failure mode, every cause, we should get an RPN score. And once you've done your FMEA, focusing on high severity failure modes is top priority, then a combination of high severity and higher occurrence scores, and then a Pareto of RPN scores. So again, we'll cover those things in a bit more detail later. But those are some of the hard requirements that are in there, but it is caveated with unless agreed with the customer. So let's look at a couple of other ones then. So using a cross-functional team. This isn't just for Process FMEA, this is for APQP. All of APQP, from the very first sort of conceptual activities right through to sign off, should be done using a cross-functional team. And when you look at the reason that is, we've got, you know, some examples here. So there's a study that was done 20 years ago, which looked at what's the chance of success if you were working on your own versus if you had 3 people working as a team. Okay, and this was actually to do with problem solving. So using the chat function, can you just type in as a percentage chance of success working on your own? Is it 10%? Is it 50%, 80%, 100%? And Rudy, if you just keep an eye on the chat, I can't actually see the chat function, but if you kind of read out some of the answers we get, could I ask you to say, what is the chance of success working on your own?
So just let me see, from from 10 to more than 50%.
Okay, so 59% is what the study showed. Now, my first experience of FMEA was like this poor man here, you know, working on his own. I was a new quality engineer working for an automotive company. I'd been in the company for maybe 4 weeks. And my manager came in with some sheets of blank A3 paper, a ruler, and said, oh, we've got the customer coming in this afternoon. He wants to see the Process FMEA on this new part we were building. Here's something that we did last year, kind of use that. But have a go at trying to complete it. And I couldn't even spell FMEA. I'd never heard of it, never seen it. But my exposure was, the way the company thought about it was just to put their most junior quality person in a room with a ruler and a sheet of paper and to have a go with it. So I was nowhere near 59%. I was probably 0%. So if 59% was for the individual, now we're going to get 3 subject matter experts in the room working as a team. How effective do you think these guys are going to be? And again, if you can use the chat function to, you see an 85% come in, 99%. Cindy says 100%, 90%, 85%. So in the study, it came out at 99.9%. And you can, it's shouldn't be a surprise that most of us may have done a team survival exercise as part of maybe problem solving, where you've got to, have a scenario, you're crashed in the desert or you're crashed in the jungle, you've got 10 items, which are the most important. You score the list on your own and then you get together as a team and you do it. And the team always beats the individual accuracy on that test. And from an FMEA point of view, it's really, really important. I was involved in a problem-solving application of an FMEA where the team had got together and manufacturing engineering had been leading it. And effectively, it was a problem with surface finish before we applied a coating. And the requirement was minimum surface finish of RA2, I think it was. And the designer, who hadn't been involved in this project to date, even though they'd been building this part for maybe 10 years, said, well, what sort of results are you getting? And the ME team said, oh, it's not a problem because we know this is such a critical feature. On the drawing, it says minimum of 2. We actually blast this much harder. We probably only need to do it for 30 seconds, but we do it for a minute to make sure that we are nowhere near that minimum surface finish. At which point the designer turns white and said, well, there's only one thing worse than being too smooth, and that's being too rough, because it could have all sorts of consequences. So it was a classic example of that team, when they did the FMEA 10 years earlier, never had that conversation. And it led to, what could have been a really serious condition. So having the right people in the room with the structure that an FMEA provides is really, really important. And we'll see that again later on, I think, with some other examples. So who would you expect to have in your cross-functional team? Well, typically, it's led by your manufacturing engineering team. It might be manager-led, it might be a senior manufacturing engineer. But some of the key players you'll have, somebody from operations, because they've got a lot of insight about how this process works with them today. Maintenance, as we'll see later on, it plays a big part in terms of influence of process and process design. Somebody from quality. So there should be a core team, typically with that type of skills. But you also need access to the designer, because there are certain parts, certain conversations you need to have with design. And again, we'll come back to that in a bit more detail later on. You may need a product supplier or equipment supplier as part of the team at certain points as well. And certainly if you haven't done many FMEAs or you're doing a very complex FMEA, having a full-time facilitator to manage the process of putting the FMEA together in the room during the meetings can be really important, because otherwise, if Jeff is trying to manage the characters in the room and go through the process, he's not contributing his knowledge to the potential failure modes or causes, etc. So having a facilitator at times can be a really good idea as well. So the next key point is you must do the FMEA at the right time in APQP. So this is one where we do see quite a few issues today. So when you look at 9145, if you look at RM13100, you'll notice that the process FMEA actually starts almost as soon as the design starts and the design FMEA starts. And there's a really good reason for that, because your FMEA is trying to inform what your process design needs to look like. If you do it too late, you've already decided how you're going to make it. You might have already bought your tool in or your fixture in. And therefore, if you identify a problem with the tooling, or a problem that could be overcome by some sort of mistake proofing on the tooling, it's too late because you've already spent your money and designed it. So your process FMEA has to be an iterative process. As soon as the designer's starting to think about what it is this component or this system's going to be, there should be an interaction between the design team and the process team to share knowledge, to look at potential risks, so that you can actually influence it. There's nothing worse than somebody saying, right, we've got the designs, I need to go and do the design FMEA next week. Or the process is running its first parts next week. But that reminds me, we've got to finish the process FMEA because we need to get through a gate on PPAP in 3 weeks' time. You can get some benefit from doing a process FMEA after, but the real power of getting process FMEA as a defect prevention tool is when you can do it before you've designed your process. And that's the important thing to remember in this. If you don't do it at the right time, you are limiting the impact of this as a tool for defect prevention. Okay. Now this is the bit. If we were doing this all in a big room together, the next three normally cause a sharp intake of breath, a gasp. So I'm glad Becky's got everybody on mute. But what RM13004 and 13100 require is that there's an FMEA at part number level. So, we have to resist the urge to do it for what I've heard loosely termed as a family of parts or a commodity. They should be part number specific. They need to include all process steps from goods inwards to dispatch. And they need to include every design characteristic that's been defined. And that could be on a drawing, an assembly instruction, or a specification. And that scope is one of the biggest issues I think we see with FMEAs today. So why does it need to be every part number and every process step? Well, every part number is different. Otherwise, it wouldn't be a different part number. So when you're looking at a risk profile, the things that will influence the risk profile is the severity of, if something was to go wrong, how would the severity show up to the end user or to the customer or to the manufacturing process? So, in Rolls-Royce, we have a load of components that we use on every engine, turbine blades, compressor blades. But the condition in which they're operating can be very, very different temperatures, different pressures. So the severity is very unlikely to be the same on different parts if they're being used in different applications and in different systems. The occurrence tends to lend itself to, well, what's the tolerance? What's my capability of actually making that tolerance? So unless you've got a set of features with exactly the same tolerance made in exactly the same way, your occurrence scores are going to be different, and potentially your detection controls will be different. So if something's really high severity and you can't afford for that to escape, you need a different detection method than if it's a fairly benign process. So it's really, really unlikely that the risk profile between two even similar parts will be the same. And therefore, you need to apply this to every part number. And when we show reference FMEAs and things later on, you can see how this can be done really efficiently, but still get the rigor of you're actually considering those different applications and what's unique about it. Every process step, what we actually say in 30004 is it's any process step that could transform the product, intentionally or unintentionally. So if you've got a part and you're going to drill 10 holes in it, you're intentionally going to transform the product because you're going to drill 10 holes in it. Now, unintentionally, the way you store that part or the way you transport that part could cause damage. You don't mean to cause it damage. There's nothing written to say that, you know, damage is the outcome. You're trying to avoid it. But storage and transportation can often be things that get missed in the FMEA because people don't associate it with risk to the product and conformity of that product. But we also see in FMEAs that people might put in, I'm going to load my fixture onto the machine. I'm going to fill out the batch card. I'm going to load the program for this part. Those directly don't have any consequence on the quality of the part. Some of them may become a cause later down. So if you load the wrong program on a CNC machine, yeah, it's probably going to cause a lot of damage. But it's not a process requirement that should be discussed in the FMEA as a step of the process, although it may come up as a potential cause of a problem later on. And finally, every characteristic, this is the one that normally creates a bit of debate. So somebody might say, well, I got 4,000 characteristics, you can't mean I need to do all of them. The danger is, I think, is a lot of the things that cause us the biggest headaches today are things, not things that have come up in the past, not the things we've already identified as key characteristics, because they get a lot of attention. It's those things that pop up and surprise us, and then we go, oh, I never realized that was so important. So over the years, we'd have built up a history of knowing that there's certain characteristics that, if they were non-conforming, could lead to a safety incident. What the thinking is with this one is, it's not just safety issues we need to be concerned with. Any quality non-conformance is going to lead to unnecessary rework and therefore additional cost and delivery delay, maybe. If we concess it, again, you know, we might be having a suboptimum system and additional cost. And all delivery delays, well, I'll say that again. More than 60% of all of the delivery delays we get in Rolls-Royce are caused by quality issues somewhere in the supply chain. So all of the delivery penalties or the expedited transport we need to put on, those in many cases come back to something went wrong with quality. So we have to consider everything, and we have to make sure that the controls are in place to try and ensure we have a fully conforming part every time. Like we said earlier with the Phil Crosby quote, you know, you've got to plan it. If you don't plan it in to actually make sure that you can produce a conforming part, then we're always going to have surprises and always be on the back foot. And the way of thinking about it, you know, it is like panning for gold. You know, you need to go through every characteristic, you need to go through every process step and apply a level of rigor so that the real important issues get found. If you try to prejudge that, then we will miss things, and then we will be on the back foot and we'll have surprises, and that's the thing we need to avoid. So, you know, FMEA is the tool to tell you what are the risky characteristics or the risky processes. We shouldn't try to pre-select what we put into that process. Let the FMEA do that job for us. And the other key point is, you know, our parts, our products can be in service for up to 30 years. So the investment in time up front to get this right can avoid 30 years of concessions, 30 years of rework, 30 years of potential quality issues and delivery delays. So there's always a business case to do this stuff up front. And out of all of the things we do, these are the things that we shouldn't be looking for shortcuts on. Okay. The failure modes must always describe product defects. So we are going to cover this a bit later, but there's a real important piece of alignment so that if your failure mode isn't describing a product defect, then we probably haven't got it right, and we're looking at the wrong thing using the tool. So we'll cover that a bit later on in more detail. If we do all of the FMEA, there's nothing worse than seeing FMEAs and no actions. So it's really important, I think, here that if you do the FMEAs early enough, so you can influence the process, influence the design, there should be a whole host of actions that we're identifying. If we don't do that at that time and we get into production, we are more limited to what we can actually do once we're in production. But there are still things that we should be looking at to reduce that risk profile. And finally, you know, this FMEA will live with the product for as long as we make the product. And as I said, that is, you know, 20, 30 years. So it's all, think of it as a knowledge management hub. Every time we learn something, every time we see a good practice somewhere, every time we've had an escape and we've evaluated it and what we're going to do to stop it happening again, we need to keep on putting it into the FMEA so we can learn from it. We can make this product better, but also we can make all of the other products better that will use this FMEA as an input going forward. And the types of changes, well, as we've said before, it's design, process, and source changes. But we should be looking at our manufacturing non-conformance data. Did we get it right? Is there anything we're seeing at inspection that we didn't identify on the FMEA? If we did identify it, did we get the occurrence level right? Did we get the detection score right? So there's a continuous feedback loop of how accurately did we get the FMEA right when we first did it. We'll have feedback from customer. We have the luxury of having loads of in-service data of from engines that are being repaired or being serviced. And obviously we've got information from similar products so we can read across and update our FMEA. This is why this is such an important document. Everything we know about how we make something should be captured in this FMEA, you know, and we should really use it as that knowledge hub. Okay, so that takes us to halfway. Rudy, are there any questions? Or do you need
yes,
a minute
Ian.
to go through any?
Yes, we have a couple of comments and a few questions. Very interesting questions. So let me see. The statements are, so a customer does not have to invoke AS13100 to mandate APQP. If they already invoke AS9145, do they? And we have customer dictating what goes on our FMEA.
Sorry, the last bit of that question, the customer dictating what goes on our FMEA.
Yeah.
I'm just trying to understand the context of that last bit. Is that saying that AESQ should not be dictating these requirements, or?
So the customer, will say and will dictate the supplier how to carry out, how to perform an FMEA.
Yeah, and that's simple. So as an engine manufacturer, the regulator looks to us to make sure that our products are safe, and 80%, well, 75–80% of our products come from the external supply chain. How we demonstrate to the regulator that we have a system that produces conforming parts, conforming engines, we are accountable for our suppliers' performance. So you will see things like Sabre, because for Rolls-Royce, Sabre was the document that took what the customer flows to us, what the regulator flowed to us, and what we knew about best practice or levels of control based on things that go on in the past. You put those into Sabre and you flow it under the supplier for them to comply to. So it's not advisory, it's to comply to, because that's the way we can say to our regulator, this is how we're managing our supplier, and what we are doing to be really clear with the supplier, what the requirements are. So with 13100, we are being prescriptive on how we want things, because our history tells us that when we go to evaluate things like FMEA, or it might be gauge R&R, even problem investigation reports, we see such a wide range of ways that they've been deployed. Some with really good practice, some with less so. We are trying to set the bar for what is acceptable. So as a customer, I am going to be really interested in how well our suppliers are doing this stuff. Because at the end of the day, I'm the one who's got to stand up in front of my customer when something goes wrong. I'm the one who has to stand up in front of the regulator and explain it. So I want to make sure that these things are being done really effectively. And when we come on to the second part, and we see what good looks like in this space, maybe it'll come more to like just how different many organizations actually apply FMEA. Hopefully that's helped.
Okay, I think so, Ian. So another very interesting question is the following. How can we know the application of the product if the design, so the customer is not sharing information with us as a supplier? So what shall we do?
Yeah, I mean, that's a great question.
Yeah. What shall we do? What shall we do if there is no key keys given by the customer? Our product often goes to stockholders. We don't know the end customer.
Yeah, so I think the stockholding context is really interesting, because this, as a requirement, is really for the organization that makes the product. So if you are a manufacturer and you're manufacturing products and you're doing a process FMEA, absolutely you need design input to help you understand what the effects are if non-conformance was created, and to help you do the severity scoring. Now, that shouldn't prevent an FMEA being done, but if we're going to do it with all of the value that it needs, absolutely the manufacturer needs input from design. And if that design is at a customer, you need to be a demanding supplier of that customer to be able to support it. And there's various ways we've seen suppliers do that, and again, there's a couple of examples later on today that we can kind of highlight that. But there's no way around it. To do this, you will need to work with customers and suppliers in order to get all of the information you need to make this a really effective approach.
Okay, thank you, Ian. Maybe another very interesting question is the following. We are keen to understand how much time we should spend compiling a PFMEA. Can it be characterized by minutes per feature?
Oh, sort of. My very last slide today will have some examples of how long it takes. If you come back on webinar 3 and look at reference FMEAs, I'll show you a way of really reducing the amount of time the team needs to do to actually work through a part-specific FMEA. But hang on to the last slide and I'll show you, I'll be able to give you a number of engineering hours per 1,000 characteristics. But the reference FMEA is another great way of reducing that even further.
Okay, and as a last question, Ian, what about a well-established company that has not adopted FMEA? Is it ever too late to start using FMEA?
No, FMEA will benefit anybody that uses it. So, you know, from a requirements point of view, 13,100 only requires you to use it as part of APQP, which is only required for new products, changed products. But we've seen a lot of organizations apply it to how they produce things today retrospectively and get benefit from it. I honestly believe it's one of those things where, you know, the task might seem big until you've done a few and you realize that actually, you know, you get over that inertia of it isn't as hard as it seems. It doesn't take as long as we thought. And actually it started to uncover a lot of things that would make our processes even better. And sometimes those things are, you know, suspected in the organization long before the FMEA gives you the information and the data to prove it. But FMEA will benefit any organization.
Okay, thank you, Ian. That's it.
Thanks, Rudy. Okay, so we've been through the kind of hard shell requirements, 13,100. I'm going to take you through now the sort of 13,004 process, or the Chapter 5 that 13,100 calls up. What does that actually look like in practice? And let's have a walk through the template with an example to try and bring it to life a little bit. So people may have come across FMEAs in lots of different ways. So in Rolls-Royce, there's 3 product types of FMEA. We have a system FMEA, so that's for the whole engine. So we have a load of very, very clever design engineers sitting in part of the business that look at the design of the whole engine, what it needs to do, what it needs to weigh, the thrust, the efficiency, and they're looking at really, you know, the sort of subsystems and how it comes together. So it's looking at, you know, the low pressure compressor, it's looking at, you know, the turbine and how all of these systems interact and what types of things could go wrong at a system level. So it's the first time we're kind of seeing the architecture and they're working through, you know, is this going to be able to deliver the power at that weight and that efficiency to meet what the customer wants. The second time is the design FMEA. Now, the design FMEA is, you know, when you look at it, it's using the same template effectively as the process FMEA, but it is very different. What the design FMEA is saying, if my customer wants the requirement for this engine to weigh you know, a metric ton, how could my design fail to achieve the customer requirement? Okay, so I've just specified it all out of cast iron. All right, okay, well, that's not going to work. So we better go back and look at it again. So the design FMEA is looking at things through a, how can my design fail to meet what the customer wants from this product? Okay, and if it's done at the right time, the things it finds, it's got time to feed it back into the design, change the design, and then ask the question again, how could this design fail to meet the customer requirement? And then the process FMEA, which is saying, okay, so with the process I'm going to use to make that design, what could go wrong in the process that means I could fail to meet the design intent? And normally that's the drawing or the assembly instructions. So how could my process mean that I fail to hit that design intent is the real question on a process FMEA. So typically those are the three we look at. 13,100 and 13,004 have requirements for both design and process, but it doesn't cover system. But you will have come across maybe FMEAs in a different context too. So when the automotive companies designed what they called the blue books, which were things like our reference manuals that Ford, GM, Chrysler developed. Around FMEA, they also created a specific application of the methodology for tooling and equipment to define how to design tooling equipment, but also how to maintain it. And if you want to know more about it, those books are available. You can still buy them now. It's absolutely a fantastic resource on how to take this approach and apply it to tooling and equipment design. You know, I've seen people apply it to business processes. It might be a HR recruitment process, it might be a financial planning process, but the thinking, you know, you can apply the thinking to those sort of transactional processes too. And as we talked earlier, absolutely you can use it as a tool for helping you solve a problem or to verify a corrective action. So in the context of FMEA and 13,100, for these webinars, we're only looking at the process FMEA and what we need to do to ensure defect prevention on products. Okay, so we acknowledge there's other applications. This is all about the process FMEA. So when you're creating a process FMEA, there's a lot of part-specific things you would typically need to be able to create your process FMEA. So obviously you need the engineering drawings, specifications. You're going to need the process flow diagram to say at each step, what am I expected to create or to assemble? The characteristics matrix, which is in 13,004, is a brilliant tool that really does the first two boxes for you. It lays out all of the features you're creating by process step. If you're assembling, like we assemble engines, you know, the assembly instructions would be our starting point. The design FMEA, the only note of caution on design FMEA is without the designer, the design FMEA is written in a strange language that very much needs interpretation. It's not a lookup guide. So if you said, what would happen if this hole was too big or in the wrong location, you wouldn't be able to look at the design FMEA and say, all right, hole too big. What's the problem with that then? The design FMEA has a lot of rigor into it about how the design could fail to hit the customer requirements. You would need the designer to come along and interpret what's in the design FMEA to answer some of the questions that would come up in a process FMEA. And the design FMEA will also generate, well, what are your key characteristics? What are the things you need to pay special attention to? All of those things, if available, are part specific and would be fed into the team. There is benefit in looking at some things you can read across. So you may have FMEAs from similar products. You might have control plans for similar processes. non-conformance reports, maintenance reports, etc., all of which will give you some insight into the sorts of things that can go wrong on other processes and other products. The output, well, you're going to get the information you need for the control plan. You're going to get a completed FMEA with risk improvement plans, and you may identify new product and process key characteristics, because it's not only design who can say what's important. Once you've run it through the Process FMEA, you might identify a whole host of things because of the way you make it or inspect it, become important and become a key characteristic because of the way the process delivers it. The other thing, hopefully by Wednesday, you'll say, well, reference FMEAs are absolutely vital to the success of deploying Process FMEAs in my organization. If you have reference FMEAs, it will greatly reduce the time it takes to put this information together, and you can use the team to really focus on the real value-added engineering stuff and less about the technical admin. So this, for me, is really key. It's the FMEA template. And if we use the template correctly, it will lead you through quite easily how an FMEA is created. So I've split it into 6 sections along the top. Section 1 is really just defining, well, where am I in my process? What's the process step? And what am I trying to achieve? Normally, if for a machining process, it's quite simple. What is the features? What are the characteristics and the specifications that I'm trying to do? If it was an assembly operation, it's what are the assembly instructions asking me to do at this point in the process? Remember, it needs to include all of the design requirements, but really this is just defining what am I trying to do. So it might be, if I'm drilling a hole, it might have the dimension for the hole, the location of the hole, etc. Those are all captured in section 1. Section 2 is, well, how could you fail to achieve those requirements? So you're going to look at, well, what's the failure mode? So if you're trying to drill a hole and it needs to be a certain diameter, what's the failure mode of that? What could go wrong? And how could you fail to hit the design intent? If it did go wrong and the hole was, in this case, too big, what would the effect of that be on the product? Both to the end user, maybe there's a customer in between the end user and yourself, or further on down the process. And if it did go wrong and that effect was seen, how bad would it be? What's the severity? What's the impact if it was to go wrong? And we'd use a scoring guideline for that. The important thing, section 1, section 2 is all about the product. Okay? The requirements are defining what is it about the product that you want to do. Failure modes, effects are all about what would happen if the product was non-conforming. Okay? And it's really easy, and I'll show some examples certainly tomorrow, but maybe on Thursday too, about where that can get mixed up and we end up fixing the wrong problem. So section 1 and 2, you should be talking about the product. The reason the Process FMEA is a Process FMEA is really because of section 3 and 4. Section 3 says, well, for that failure mode, the fact that the diameter is too big, what would need to happen in my process to make that happen? Okay, and it should be fairly direct cause and effect. We shouldn't be saying operator error or poor work instructions or no maintenance. It needs to be, sort of hole too big, all right, the drill's oversized. That would be a cause and effect. The prevention controls is, well, how could you stop that failure mode from happening? How could you stop the drill being used, being oversized? And the other last part, the other scoring part is, well, how likely is it to go wrong? So how often do we have the diameter oversized? How often do we use a drill that's oversized? So what's the likelihood? And again, there's guidance on how we would score that. But in section 4 is about detection control. So if the failure mode happened, in this case, hole oversize, or the drill was oversized, how would we detect it? So detection controls are looking at failure mode and causes. And the detection score is, well, how likely are you to find it if it did go wrong? Again, on a scale of 1 to 10, where 10 is you've got no chance of finding it, 1 is you can't miss it. So sections 3 and 4 are all about the process, hence the name Process FMEA. We then have risk mitigation. So once we've got that far in your FMEA, you can calculate what the risk priority number is, which is a relative score of risk for all the things you've identified. And then that leads you on to how to identify the things you need to focus on for improvement. So 5 and 6 is all about risk mitigation. So just to illustrate that, here's an example. I'm at Op 10, and Op 10 is CNC drilling operation. I've got a requirement of drilling a hole 50 millimeters plus or minus 0.1 diameter. So there'll be lots of other requirements for this hole, such as how deep is it, the location, etc. But I'm going to start with the first requirement, which is the diameter. So how could I get that diameter wrong? Again, you can use your chat function. And let's see how you would answer that question. What would the failure mode be for 50 millimeter diameter plus or minus 0.1? Suzanne Hill, hole too big. Matt, too big. Oversize, undersize. Wrong drill bit. Drill size. Too deep. Okay. So, now the first list, because I've seen wrong drill, too deep, not through, wrong position. That's all great stuff that makes me think that tomorrow's session is going to be quite good as well. If you look at the information flow, all the information you've got so far is about the diameter, okay? And the failure mode has to be linked to that statement of 50 millimeter plus or minus 0.1 diameter. So there's no information in there about depth. There's no information in there about location. So you don't need to worry about those because you're only answering the question on diameter. So if you said oversize, undersize, well done, because that's absolutely right. So the way you could get a diameter wrong is either make it too big or too small. Things like wrong drill bit is not a failure mode. It might be a potential cause for a failure mode. So if you say I've used the wrong drill and it's too big, yeah, well, that's a cause for what can make the failure mode too big. So one of the key things to kind of get your mind into gear, when you look at how the information flows left to right, it has to be joined up, almost cause and effect. So for this one, how can you get a diameter wrong? One of the ways is you could make the hole too big. Okay. The other one is obviously you're making it too small, but there are no other ones. The failure modes are finite when you actually describe them this way. Now later on, the next requirement could be hole depth and it could be hole position, but at the moment it's only saying diameter. So what's the effect of this hole being too big? This is where your designer, with his DFMEA, can be important. So the designer comes in and he says, right, if this hole is too big over time, that can cause movement, that can lead to engine vibration, and if this part vibrates, it could lead to a fuel leak, which could lead to a fire, and we'd have to shut the engine down. So yeah, it's related to the fuel system, it's high severity. the manufacturing engineer says, well, if this part is too big, because we know it's a high severity failure, we wouldn't concess it. We can't rework it because the hole is too big, so we'd end up scrapping it, and that's a 7. So between the designer and the manufacturing engineer, they've worked out that these are the effects. There might be other ones, but there's 2 effects, and this is how they scored it. The next thing to look at is what's the potential cause of the hole being too big. And this is where the team have identified 3 potential causes for hole too big. So they've said, well, the drill could be oversized. The part could be loose in the fixture, so that as the parts move in, the drill bit in there is moving against it, and that could make it be too large. Or maybe it's the spindle alignment. That's not true, and therefore that ovality is going to cause the hole to be too big. Once you've got the cause, there may be other causes too, but once you've got the cause, you can look at, well, is there anything we can do to prevent using an oversized drill? In this case, we've said, yeah, we can use a preset to check. What about part loosened fixture? Okay, we've got a fixture check pre-machining. So it's important that prevention control are things you do to stop it from happening and not catch it if it does. And then spindle alignment, yeah, as part of our preventive maintenance, we've got a laser check that looks for spindle alignment. And then the next one, detection controls. Well, normally there's a detection control for the actual failure mode. In this case, we are measuring it at a later op using a ball mic. They've also identified that there's a spindle ball bar check they do weekly, which would catch it if it did drift, but it's not a preventive maintenance check. So it's not particularly effective, but it's something that they do. Once you've got that, you can work out the RPN, and that is flowing out. So from this example, this is it after you've tidied it up. It's important to note that the information flows in a certain way, and if you look at the requirement of failure mode, the failure mode should drop out of that requirement description. So for diameter, you can only be too big or too small. If it was a depth, you can be too deep or too shallow. If it was a length, it can be too long or too short. But there's only so many ways a requirement, if it's specified correctly, the failure mode should be a natural consequence of that description. And in the same way, as you move to the right, the potential causes are things that could cause that hole to be too big. Right? And they're very specific, and they're very cause and effect. So it's something to remember, and the problem we often see is where the failure mode is not linked to that requirement well enough, and it actually describes process failure mode. So in this case, drill breaks or oversized drill used, if we had that in the failure mode, it's actually describing something in the process and not on the product. So the other sanity check is if you can read a failure mode and it's not describing something you can see or measure on the product, then it's probably incorrect. Okay. Now, the other thing to bear in mind, the precision of language is really important. This FMEA will be around this for 20 to 30 years. The team that creates it will not be the same team that maintains it. So it has to be able to be picked up by somebody else, read and understood. So again, it's really important. If this was a real example of an FMEA, there'd need to be much better descriptions in that. So we've touched on this, but just to show where some of the information comes from. The operation step, well, you've got a process flow diagram or characteristics matrix. The requirements, you might need the drawing, assembly instructions and specifications as well to list those out. The failure modes, we haven't covered reference FMEAs yet, but if you had reference FMEAs, all the failure modes for every type of characteristic would be in that database for you to use. You may have similar part FMEAs you can use, or the team needs to generate it for the first time on its own. Effects of failure and severity, that's where your designer and your design FMEA play a part, okay? But it's not a lookup task of looking at the design FMEA. You need someone to interpret it to answer those questions. And for things internally about how that failure mode could influence later operations or scrap or concessions or rework, that should be in the manufacturing engineer's knowledge. So we should be able to capture that with or without the designer or a design FMEA. The potential causes, prevention, detection control should be in your reference FMEA if you have it. Otherwise, it's down to your team to identify it. Detection controls, detection scores, again, will be in process flow diagrams, characteristics matrix, your inspection plan, or similar part control plans. And your current score, how often do these things happen? Then, you might have capability information, you may have scrap reports, maintenance records, etc. That will help you say, well, how often do these things occur? When it comes to scoring, severity, occurrence, detection, there are 3 tables in RM13004 that should be used. Again, we've only softened the language that should be used because you may have an alternative that would be acceptable to your customer. And if that was the case, you could carry on using your own. Otherwise, we'd expect you to use these in 13004. So once we've got the scoring, we've got the FMEA complete. We're going to go through, we're going to look at how do you calculate the RPN. In a simple example, it's as simple as this: severity score times your occurrence score times your detection score. And that will give you your RPN number. Okay, in this case, it's 100. Now, it's never going to be that, hopefully it'll never be that simple, because what you're expecting to see is for every failure mode, you're going to have multiple effects. So what is the effect to the end user? What's the effect to your customer? What's the effect to your manufacturing process? Every potential cause will have an occurrence score. So if you've got, again, we would expect you to have multiple potential causes. And there's an RPN score for every failure mode potential cause combination. So in this case, there would be 3, because there's 3 potential causes for this failure mode. And then on detection, again, you may have multiple detection mechanisms per either failure mode or the potential cause. So which one do you use to calculate your RPN? So from a severity point of view, we always assume worst case. We take the highest score. Because there's a score for every potential cause, we use every occurrence score for its own RPN value. And on detection, where we have multiple detection methods, we take the lowest detection score. And the way I normally think of this, or trying to explain this, is if you had 3 grades of filter paper that water or contamination passes through, it's the smallest hole in the filter paper will catch everything if the other ones didn't. So, it's as good as your best detection method. So in this example, you've got 8 times 5 times 5 is 200. 8 times 8 times 2 is 128. 8 times 3 times 3 is 72. So there'd be 3 RPNs based on that method. But when it comes to prioritization, a lot of organizations will just simply create a Pareto and burn down the highest RPNs. What 13100 asks you to do is slightly different. Focus on high severity scores. And we've seen some great examples where this has happened early in an APQP process, where they said, we will not allow this design to progress if it's got any severities of 9 or 10 still left in it. So those are the discussions you need to be having with design right up front. but that should be a priority. Combination of severity and occurrence scores, and then your high RPN scores. The thing to avoid is setting a threshold, because everywhere I've seen a threshold identified, you can see that the scoring is designed to just get below it, so no actions are taken. It can drive absolutely the wrong behaviour, and it's quite an arbitrary number. So what we would rather see is high severity, combination of severity and occurrence, high RPNs, as part of a plan to burn down those risks to get it to an acceptable level. In RM13004, there's also this occurrence severity grid that a lot of people like to use to kind of show where the distribution of the different risks are. And again, this is a great tool to help you prioritize what you should be focusing on. In terms of risk mitigation for severity, well, you can only change the severity score if you actually redesign the part, or you remove the need for a function, or you provide a fail-safe solution. But severity scores we are stuck with unless design can go and do something different. Occurrence scores, well, we can reduce the chance of occurrence through either mistake proofing, improving the capability of a process, and trying to find ways of making sure that our process is centered and we have process control in place to manage that. And on detection, again, the best methods are anything that you can do with error proofing. So there's been a real rapid rise in the use of things like camera systems and digital solutions that take the reliance away from human inspectors. But even, one thing we have to remember, you can't get better than a 5 on a detection score unless it's automated. So the best inspector using a CMM, the best score you can get on an FMEA is a 5 without some form of error proofing. So that, from a detection point of view, you can get into the something, well, 5's the best you can get with normal inspection. Variable inspection is better than attribute inspection, etc. So improvement actions, in this particular case on spindle alignment error, what we've done, 2 simple improvements that didn't take long to implement. What Sarah's done on this example is move the variable gauge check from a later op to the actual in-process area. And that allows her to score it as a 5 instead of a 6. Now, you can argue about is detection the right place to start, but it does lower the score. But then what Daryl has done is increase the frequency of the machine calibration so that we are preventing that sort of potential for drift between different calibrations. And that again has allowed us to go from a 4 to a 3. So through 2 really simple actions, we've taken the RPN number from 216 down to 135. Now, the question of how long does it take? So a number of benchmarking things, both within Rolls-Royce and with our external supply chain. Typically for a part with 1,000 characteristics, the thing to realize when you first do that FMEA to this method, most of the team will be on a learning curve. And so the first one is a bit of a training exercise. I mean, I've been in some sessions, there's 20 people in there because they're there to learn. You would never run an FMEA session with 20 people in the room, but some of the early ones to get people to understand the approach. That's what we did. If you extrapolate that and say, well, it's always going to be 20 people, we'll soon convince ourselves that it's something we don't want to do. So the thing to bear in mind is, as we learn, if you take a team and say, right, do your first one, your second one, your third one, it'll probably take 4 or 5 before they've really got to a level of understanding. And so in this case, it's just over 100 engineering man hours to do a part with 1,000 characteristics based on the fact that they've done 4 other FMEAs similarly before. And one of the examples I witnessed, we had a team, they were going through their first FMEA. They get to one of the first failing modes. So, well, what would happen if this, I'll use the example, this hole was too big? Nobody in the room knew, so they phoned a friend, phoned someone in design. He said, oh, I'll get back to you. I just need to speak to somebody in the labs. 45 minutes later, we get an answer. There's a conversation. It probably took about an hour to work out what would happen if that feature was wrong. But the next day on the next part, it took 5 minutes because they'd been through that. They'd learned from that. They knew exactly what question to ask the design engineer. And because this was now their second time of asking, third time, it takes 5 minutes instead of 45 minutes. Well, if you extrapolate that, that's where you get from over 400 hours down to 100 hours because the team builds that knowledge. Now, on top of that, again, I'll show you on Thursday how to use a reference FMEA to capture all that knowledge so we're not trying to reinvent it every time. This can be done really, really efficiently. And even if it was at 100 hours, taking 100 engineering hours at the start of a program that's going to last for 20 to 30 years, I think that's a really good investment on time. Probably show you some other ways in which we can reduce that further. Okay, so now we've been through in a bit more detail about what 30,100 requires and a walkthrough of a practical example. I was going to ask you, Becky, if you could run this poll again to say, well, how does what you do in your organization compare to the way we've just described it?
So the poll is live, everyone. Feel free to start voting. Okay, it looks like everyone's voting. A few more people. We'll give a few more seconds here. So it looks like not at all. We do not process FMEAs or control plans, 9 to 10%. It is very difficult to how we currently do, or different to how we currently do it, 20%. We comply with more than 75% of the requirements, but there is more we need to do, 53%. And this is how we conduct process FMEAs and control plans, 16%. So thanks to everyone for voting.
Yeah, thank you. That's some really good insights. Thank you for that. Okay, and Rudy, any questions?
Yes, Ian, there are a couple of interesting questions coming in again.
I do worry when you say interesting questions.
Yeah. So one of them is AS13100 for manufacturers only? How does AS13100 or AS RM13004 affect distributors? Is it part of our flow downs to manufacturers?
Yes, so it really depends on your role as a distributor, really. If you are accountable for the quality of your suppliers, then we'd expect you to flow it down. These are tools that need to be used by manufacturers in our supply chain. So if you have an accountability for the quality of that supply chain, then we would expect you to flow it down, 30,100 and the associated standards, because that's how we want our suppliers that with design accountability or manufacturing accountability to demonstrate that compliance and really be focused on defect prevention and not on inspection.
Okay, thank you, Ian. The next one is, should we consider pressure, temperatures, and vacuum as failure mode or as the cause of failure?
Yeah, from understanding the context, they are the causes of a failure mode. So, you know, if those pressures are part of the process, let's think of an example. We sometimes have, you know, heat treatment as an issue, and they would say, right, okay, so the temperature variation in the furnace was such that these parts didn't get the temperature they needed or the temperature profile that was specified. So temperature in that case is a cause of the fact that the material was not hardened to the right specification. And if you were looking at things like, you know, so if pressure is a process parameter, the fact that it was too much pressure, not enough pressure, or no pressure will lead to a product non-conformance. So it's the cause of a product non-conformance. Yeah.
Yep.
And when we go through the webinar tomorrow, we'll have some real examples of things that we see today that people put as a failure mode. The fact that they're identified doesn't mean that that knowledge goes to waste, but it probably shifts along to the potential cause column rather than the failure mode column. As I said, I think that the sanity check is if you can't physically see or measure the failure mode on the product as written, it's probably not a failure mode.
Okay, thank you, Ian. Maybe the next one. It is regarding your example. In the example, PFMEA, only the most severe severity score was used. Is this usual, as there is a possibility that the more severe outcomes are much less likely to occur?
Yeah, I think from an FMEA approach, now, the standard you would expect is, what's the worst thing that could happen? If you didn't take that, it might lead you to a different control plan requirement. So if you know that there is a chance that this could lead to a fuel leak, it could lead to an explosion, or could lead to a fire when the engine's operating, that might lead you to say, well, this is so severe that the controls I need to have in place absolutely must be mistake proofed. You know, so we need to spend the money and the time, because the justification is we can't afford to have that type of non-conformance. So if you didn't use the most severe thing that could happen, you might be comfortable with doing normal inspection of what we normally do. Well, that could be an issue if the severity is a 9 or 10 and we've undercalled it. So we need to use that severity score, agreed with design, absolutely. But we need to use that as the business case for why we need to invest in maybe mistake proofing or process capability improvement or detection to address that issue. Okay.
Yeah, I have no sound. It's no voice.
I can hear
Okay.
you. Yeah.
Okay, I hear you again. Okay.
Okay.
So, okay, sound is okay again. Yeah. So maybe another question concerning the ranking, the evaluation. Can severity times occurrence be priority for improvement? If yes, why is there no S and O column in the PFMEA template?
Yeah, I think you know, I've seen a huge array of different templates where people have added columns for S and O, and I think in practice we've tried to standardize around a single format, but the prioritization that we would want does include the tool, let me go back to it, which is the occurrence and severity grid. I mean, so in RM13004, putting this together really allows you to focus on occurrence and severity. We felt this was a better way of looking at prioritization than having different types of template where that's actually worked out. But we would encourage the severity and occurrence analysis to help you prioritize. Absolutely.
Thank you, Ian. Ian, that's it.
Okay. So
thank you very much.
Just a few last slides then, and then we're good to close at 4 o'clock. So the requirements I've been through today were originally in AS13004, which was published back in 2017. We have taken an opportunity to, I think, respond to some questions we had related to 13004, but the clarity of some of the requirements in there. So the intent is exactly the same as 13004. Some of the words have been simplified to make it easier to interpret. But what we started seeing, so back in 2018, Hongli Zhu from Samsuzhu on the right there presented to the AESQ Supplier Forum in Tokyo about how they used 13004 to get their products that they made for Rolls-Royce to zero defects through that application. Now, this was effectively a kind of a bit retrospective, but they did take all 16 part numbers eventually through that and made all of them zero defects. One of the reasons Samsuzhu actually won the Most Improved Supplier Award for Rolls-Royce back in 2019. So we saw a step change there. We also, GKN at the bottom, this is a presentation they made in East Hartford in April 2019. And again, this was a great example where they did put Rolls-Royce under pressure to get design involved at a very early stage. And what we saw was entry into service, at first article, was zero defects on a very complex fan case with, I think it was like 4,500 characteristics. So entry into production, zero defects, but also the other key thing was it actually took them half the time it normally did, because a lot of the problems that they would normally find that would lead to redesigns or process changes, etc., they were found much earlier before tooling and things were committed. So it actually took something like 6 months instead of the 12 months they'd allowed for it. And that's been reported by a number of suppliers who've actually been through this APQP process, but in particular, the Process FMEA. And then also we had FACC. This is a picture from Toulouse in October 2019, where again, they shared a very similar story about how they took 13004, applied it, the lessons they learned, but also the significant benefits they saw in terms of quality performance. So we know when you do it, if you do it with the right intent, this stuff really does work. We've been through the reference manual. You can download that for free from the AESQ website. There is SAE training on FMEA that meets this intent, and it includes reference FMEAs and all of the things that are aligned to 30004 are in the SAE training. And we do have a subject matter interest group, which is contactable through the website. So if you type into Google AESQ, it'll take you to the landing page on the left, and you will see on there then there's a link on the top to interest groups. and there's a number of different interest groups. But defect prevention, you can see is the top right-hand side of that list. And if you click on that, that takes you to our defect prevention tools page, where this webinar is listed, but also at the bottom of that page is a contact the interest group link, and you can send us emails. You can ask us for what would you like us to be doing next? Is it other training? Is it webinars? Are there other things that we could be doing to help you with your deployment of RM13004? So that brings us to the end of session 1. So we've been through the requirements of 13100. We've had a high level overview of what a process FMEA would look like that meets the intent of 13100. Tomorrow we're going to spend a little bit more time going through column by column and showing what's meant. We've got some examples. We can talk through some of the pitfalls to avoid and some of the best practices we've come across. So that's tomorrow. We've allowed an extra half hour tomorrow just because it is a lot of material. But hopefully we can get through that, and you'll find that really useful, particularly if you're involved in creating FMEAs and control plans. And then on Wednesday, we'll go through how to create a reference FMEA and how that can improve the time it takes to do an FMEA, and also how you can use that information to create your control plans. So based on that, I'd like to thank Becky and Rudy for their support as we've gone through today. And in particular, I'd like to thank everybody on the call for taking part, for listening, for taking part in the polls and the questions as well. I hope you found it useful, and I hope we'll see you again tomorrow to do part 2 of this webinar. Thank you very much.
Thank you very much also from my side. Thanks a lot. Have a nice day.